Hello everyone, a very warm welcome again to the virtual session of science. I hope you all are doing very well, children, and I'm very much hopeful you have already started in writing second term portion in your notebook. I hope you all have followed the instruction given in the Zoom session. So please write second term and in your index as well, and please start writing the points which I am going to discuss in the virtual sessions, children. And please see that we are going to start. We are going to continue with the chapter which we have already started in the Zoom session. That is light, shadows, and reflections, part 2. So I hope you all have started writing in your notebook, and this is where your second term begins. So please make a note of it. Please write second term for this chapter. At the beginning of this chapter you can utilize one of the page and write second term, and then start writing the new chapter, that is light, shadows, and reflection. This was already instructed to you all in the Zoom session. Let us see what are we going to have in this session. We are going to learn about the pinhole camera. Since we are learning about the light, shadow, and reflection, we need to learn about this concept. What is pinhole camera? Formation of image by pinhole camera. A pinhole camera is a simple camera that consists of a light-proof box, a thin film for a screen, and a small aperture or hole to allow the passage of light rays. The light from outside enters through the small hole and forms an image on the screen that is inverted. So please take down all the important points for the pinhole camera, and this is how pinhole camera is made. This is the making of the pinhole camera. Please write down these notes, children. Then image formed by pinhole camera. How the image is formed? Images formed by the pinhole camera are upside down. Here is a picture showing the path of rays of light coming from an object far away to a pinhole and then to screen. Let us see. This is a pinhole camera, and you can see the image of the tree. When you see through pinhole camera, it will be inverted. It is upside down. Can you see this, children? Just have a look at this. So the image form will be totally upside down, because you can see the light rays falling on the tree, and when it coming back to the pinhole camera, you can see the image form in the pinhole camera will be upside down. This is what you see, the inverted image in the pinhole camera. When sunlight passes through the leaves of the tree, the gaps between the leaves act as the pinholes. This natural pinhole casts nice round images of the sun. This is a very good application. You see like a naturally made pinhole camera, and you see in the nature. All the points to be taken in the notebook. Now let us see what is rectilinear propagation. Since you are learning about light, you need to know how light rays move, how they propagate, how they will move. Let us see. That is rectilinear propagation. That means in a straight line. Rectilinear itself means in a straight line. So light takes the quickest path between any 2 points. Therefore light travels in a straight line. This is known as rectilinear propagation of light. Very, very important. That means light always travel in a straight line. That's why it is called as rectilinear propagation of light. Here you can see it is a proof of a rectilinear propagation of light. When you have this kind of experimental setup in the lab, you have a candle lit at the other end, and you have boards kept ABC with the holes, and you keep an eye there. You can see the light rays which will come to your eyes. It will fall on your eyes, and you will see the light is following the straight path. That is, it is following the holes which you have made on the board ABC, and you can see you should make the hole at the same point on all the boards, so that you are able to see the light which is coming out of candle, which you are going to light the candle, and you will see the holes which you made in the board ABC. The light rays will travel in a straight line and it will reach to your eyes. This is a very good example and an evidence to show that light travels in a straight line. Just have a look, this kind of experiment we do, and if light were not in a straight line, then the light rays from the candles will not reach to your eyes. This is how it is shown that light travels in a straight line. Propagation of light. Usually light travels in a straight line. When we want to represent the propagation of light with a diagram, we represent with the help of rays and beams. So we show rays and beams, and that shows a straight line propagation or the rectilinear propagation of light. So let us study more about this. A ray is a line with an arrow that shows the direction of propagation of light, and such a diagram is called a ray diagram. So what is a ray diagram? Which is here a ray diagram is used to show a ray which has an arrow, as you all know, and the arrow shows the direction of propagation of light. Whichever direction you want to show, you can show the arrow on that particular side, on that particular direction. So the arrow will help us to locate the direction of the ray of light. This kind of diagram when you draw is called a ray diagram. Beam. What is beam? A group of light rays moving in an organized manner is called a beam of light. So there are differences between a ray of light and a beam of light. So what is a beam of light? Is a group of light rays. So light ray will consist of one single ray shown the direction of the light ray, and it will help to locate the direction of the light. Whereas beam of light, when you're talking of many light rays together, will become a beam of light. So it's a group of light rays moving in an organized manner, that is a beam of light. Here you can draw this diagram. Please draw this diagram in your notebook, children. Extremely important to understand the concept of the ray and beam of light. So representation of light as rays and beams, you can show the diagram A on the extreme left is a ray of light. Diagram B, a beam of parallel rays. Diagram C, a beam of rays coming from a point source of light. So you can see the group of light rays together becomes a beam of light. So a beam of light can be in a parallel direction, or it can be from one single point source, and you can see the light rays coming out of it. So if you have a bulb and you see a beam of light coming out of the bulb which is switched on, so that bulb, one single source, will give out many rays, and that many rays becomes a beam of light. I hope concept of ray and a beam of light is very clear with you all. Please draw this diagram in your notebook, children. Now the property of light to travel in a straight line explain many interesting phenomena related to light. Please make these points in your notebook. So when you have the property of the light which moves in a straight line, there are extremely important phenomena which is related to light, that is like formation of shadows by opaque objects. So how shadows are formed? Because light travel in a straight line. That's why you can see the formation of shadows. You all know what are shadows, and shadows are formed due to the propagation of light in a straight line. Next important phenomena, formation of images in pinhole camera, which we have seen how pinhole camera is made and how images are formed in a pinhole camera, and this happen only because light travels in a straight line. And these two important phenomena you should know, that in a pinhole camera you see the images form and you see shadows formed by opaque objects. So opaque objects only will form shadows, as you all know. Please do write in your notebook, children. I hope you will have taken down all the important points discussed in this session. So here we come to an end of the session, children. Please do make all the very important points for this chapter in your notebook. Just a reminder to you all. Thank you, children, and have a wonderful day.